Everyone, today we are going to talk about primitive data types, variables, and expressions. This material is covered under Learning Objective 2. Evaluate an arithmetic expression using order of operations, promotion from integer to floating point types, and integer division. So we'll start with the idea of evaluating an arithmetic expression. But before we get into that, I actually want to make an analogy with English language sentences. So we're going to make an analogy between a sentence and an arithmetic expression. The example that I have in mind is a sentence from Franz Kafka's Metamorphosis. As Gregor Samsa awoke one morning from uneasy dreams, he found himself transformed in his bed into a monstrous vermin. Nowadays, I think it's not so popular to do sentence diagramming, but perhaps there are some people in the audience who did this perhaps in 6th grade language arts class. But the idea is a sentence is built up out of constituent parts. If you know that Gregor Samsa is the subject of the sentence, then that starts to give you a sense of what the sentence means. Other things that help you extract even more meaning from the sentence is the fact that you know, for example, that uneasy is an adjective that modifies the word dreams. Monstrous is an adjective that modifies the word vermin. These things are important towards understanding what this sentence means. And similarly, an arithmetic expression that we're going to talk about what it looks like in Java will have this similar sort of buildup. So instead of having words, we have what we call primitives. So that might be numbers or strings or simple operators. We'll look into some examples in a little bit. And the syntax of a programming language is the proper way to build from those primitives. Now, once you have built an expression, an arithmetic expression, or an English language sentence using properly formed syntax, then that sentence will have some semantics associated with it. It has a meaning. And furthermore, there is in a programming language a single meaning that sentence or expression can have. In English, of course, you can have some ambiguity. That should not be the case for programming languages. So hopefully this analogy is making things clear in your head, and to further make it concrete, we'll look at what do I actually mean by primitives and how do we build them up. And the way that we do that is, well, they're arithmetic expressions, which means that we're going to use arithmetic operators. So addition, subtraction, multiplication, division, and modulus. The modulus symbol is a percent sign. It is not taking percent, though. And going back into order of operations, as Learning Objective 2 has in it, you might remember from elementary school, maybe middle school, order of operations. You might have learned PEMDAS, parentheses, exponents, we won't see those. Multiplication and division go from left to right, and addition and subtraction go from left to right. So that remains very similar. The only new thing that you may not have seen before is the modulus. So modulus is kind of grouped together with multiplication and division. So I would do it as, modulus, multiplication and division, and then addition and subtraction. And like I said, we're not really going to see exponents. That's not a basic arithmetic operation. But you can try to use PEMDAS to think about what the order is for doing operations. When we talk about these primitives, they consist of data types. So I have here a list of the basic primitives, the basic data types that Java has. For our purposes, there are going to be, in this particular set of slides, there's going to be 3 that are important: int, double, and float. So here's int, here's double, and here's float. And int you can think of as an integer, so basically a whole number. And so, 7 is an int. Double and float, on the other hand, are what you might usually think of as decimal numbers. The only thing is that we need to think about what sizes these numbers are. You might think about the size of a number as being how many digits it is, but for computers, we're going to use bits. So an int can be up to 32 bits long, which gives it a range of what numbers it can be. And similarly, a double is 64 bits, where a float is only 32 bits, but it allows for decimals. And it's called a double because it's literally double the length of a float. We're kind of starting to have a sense, at least in theory, of what it means to evaluate an arithmetic expression using order of operations. We kind of understand the difference between ints and floats. And now I want to talk about integer division. When you divide two numbers that are ints together, you will also get an int. In math, we are used to seeing, for example, 10 divided by 4 is equal to 2.5. But in Java, when you do 10 divides 4, you're going to get 2. In other words, you will only get the whole number part of the division. And that's because integers do not contain decimal points. So that's what modulus is. Modulus is the remainder in whole number division. I have two examples here. 5 mod 2 is equal to 1, because if you divide 5 into 2, you would get 2 with a remainder of 1. You can also have a remainder where the number is just itself because it's smaller than what it's being divided into. So 4 mod 8 is just 4, because 4 divided into 8 is 0 with a remainder of 4. Now, another symbol that you will have seen when evaluating expressions or doing arithmetic equations before is the equal sign. But equals means something a little bit different in the context of programming language. It means assignment operator. Basically, programming uses left to right association to assign values. And the way you can think about this is there's going to be a memory address that we write on the left-hand side, and then we put the equal sign, and then we'll put an expression. And basically the way that you can think about this is as if you are putting some expression inside a box at a certain address. So here I have the example of length is equal to 7. So you can imagine that there's a memory address that we know we can access by the name length, and we just basically say that the number 7 is in there. The second example I have here is x is equal to length times 5. So x is another location, and if length is assigned, we can say, okay, it's 7, so x is going to be 7 times 5, which is 35. Something that would not work and doesn't make sense is 7 is equal to length. A number 7 cannot be a memory address in that form. You have to use some sort of actual naming to get there. So 7 is equal to length doesn't make any sense. I think we have enough information to think about what it means to assign values to variables now. I already gave you a little bit of an example before, but now let's make it more concrete with this rectangular prism. A rectangular prism can be defined by its length, width, and height. And that's exactly what I'm going to do. I'm literally going to say, look, the length is 7, the width is 2, and the height is 9. And because I'm declaring them, I have that address on the left-hand side, which are named length, width, and height. And then I assign them to some sort of, in this case, a number. Because this is the first time I'm doing this, I also have to say what the data type is, which in this case, I'm going to have it be int. Then you can have something a little bit more complicated on the right-hand side. So for example, I might say int area is equal to 2 times, with appropriate parentheses, width times length plus width times height plus length times height. So here, what I'm doing is I'm calculating the surface area of this rectangular prism. So from this slide and the previous one, keep in mind that we're naming things and then we're assigning them to different values. And the other thing I need you to take away is that the first time we instantiate a variable, we need to include its data type. Another thing that you can do with basic arithmetic operators is increment and decrement. So we just saw that the first time you declare a variable, you call it by its data type and give it a name, and you can set it to a value if you like. So for example, let's say I initialize this int data type that I name I as 0. And now I can do all sorts of things with it, which is going to be this list of increment and decrement. Basically, you get used to the idea of doing plus plus or minus minus together. And you can do either pre or post increment or decrement. So what does this mean? If you do something like I plus plus, then it actually increments the value I. So now, where I before was 0, it's now equal to 1. One thing that's a little bit weird here is that since you do I plus plus, it actually gets incremented after whatever is happening in the expression. So you can think of this as, I'm going to print out I, which is currently 0, and then I'm going to add 1 to I. System.out.println I plus plus. On the other hand, if you do a pre-increment, you would do plus plus I. So from the previous line, I was already set to 1. Now plus plus I is going to make it 2, and it's going to then evaluate this println. So that's going to have it print out 2. Similarly, you can pre-decrement and post-decrement. And because this is a quick way to write it, it is often used as shorthand. And of course, you can use whether it's a post or pre increment towards any sort of other logic you might want to use when it is appropriate to do so. This continues with augmented assignment operators. So I showed you I plus plus, but if you wanted to add a different number, then you might want to do addition, assignment using plus equals. So if you do something like I plus equals 8, then that gives you I is equal to I plus 8. Okay, so that's what that operation means. You can similarly subtract. I minus is equal to 8, which is equivalent to saying I is equal to I minus 8. The idea here is that the I that appears on the left-hand side of the weird little double operator symbol thing that we have going on it refers to the address in memory. The I on the right refers to the value at that address. One thing that might be interesting to try is to do a system.out.println using something like I plus is equal to 8. And I would love to see, you can tell me what happens if you try to put I plus equals 8 in a system.out.println. Does it print out the previous value of I or the next value of I? What happens? I think we are now at a point where we can do a little bit of practice. Okay, so at this point, I have given you enough information about evaluating expressions and kind of what the syntax looks like for you to try to design an algorithm that calculates the surface area of a rectangular prism. I have written out that formula again. So the surface area is 2 times the length times width plus the width times height plus the height times length. So what I want you to do in this program is come up with some numbers for length and width and height and assign variables to them. and then use this formula to calculate the surface area. And then finally have the program print out what that surface area is. So this is a good time to take a pause in the video because on the next slide I'll go over what the answer should look like. So as always, if you don't know where to start, you can start by writing out a class, and you can do public static void main to get started with your program. Based on what I talked about with creating these data types and assigning values to them, we can have int length is equal to 7, int width is equal to 2, and int height is equal to 9. So remember, since it's the first time I'm declaring them, I have to have the word int in front of it, and then I give them names like length, width, and height. Finally, I can write an expression, int area, which takes that equation that calculates the surface area. And then I have system.out.print, the area is, system.out.println area, where this word area is the same as the variable that I named earlier in the program. So give that a try and see how your answer differed from mine. Here I have a way to do the problem that's a little bit different. Length, width, and height are the same way, but I've broken up the way that I've calculated area into several lines. The idea here is that instead of declaring that whole formula all at once, I'm going to say int area, first time I declare it, is equal to width times length. Then area plus equals width times height, and then area plus equals length times height. So now I'm changing the formula as we go on. And then finally, I'm going to do area times is equal to 2. This is the same program, but now the formula is broken up into multiple lines. This could be helpful in terms of readability for you. And there might be some programs later on where it makes sense to have a partial answer for part of the problem. Maybe not in this case, but it could definitely be the case for other types of problems that you might see. The very last thing that I want to talk about is promotion from integer to floating point types. This is something called casting, and then we'll relate this back to integer division. We already learned that when you divide integers, that you only get the whole number answer part. So with this example I have here, int I is equal to 4, int j is equal to 8, I divided by j is equal to 0. So why is that? Because 4 divided by 8 is 0. Again, it has a remainder of 4. And all of the numbers after the decimal point are truncated. Now, in some situations, we might actually want to have ints, but later on take the decimal parts of numbers. So the question is, how do we get those decimal parts? What do we do to resolve this issue? Now, it is possible to do what's called cast a type. Data is just binary numbers, so we can convert one value to another through casting. So if I set a double, I is equal to 4.5, now I do have that decimal. Later on, if I want to have the integer part, I can do int j is equal to int in parentheses I. And basically that's saying j is equal to whatever the integer value of I is. So if double I is equal to 4.5 and int j is equal to int in parentheses I, j is equal to 4. You can cast it back. What if I said float k is equal to, in parentheses, the float version of j? What is that going to give me? Okay, good. So it's going to give me just a decimal version of 4. So that's going to be, in this case, 4.0. Finally, to recap, remember that we are covering learning objective 2, evaluate an arithmetic expression using order of operations, promotion from integer to floating point types, and integer division. With evaluating an arithmetic expression, we talked about what the different symbols mean and what it means to have left and right, what that means in terms of the syntax that Java will have. We talked about order of operations, which I related back to PEMDAS, including the modulus, possibly for the first time for some of you. We talked about casting between integers and floating point types in order to get decimals when necessary. And finally, we discussed what integer division means. The basic idea there was integer division only takes the whole number part of problems. I'll leave you with a small exercise to help understand the learning objective 2 a little bit better. This example, just try it out. See if you write double x is equal to 1.0 minus 0.1 minus 0.1, what is x going to be? What would you print out if you were going to write this by hand? And what does Java actually print out? Why are they different? So that's what I'll leave you with. Thanks for watching.